So this is my week 9 lab for the rolling dice combinations. Um, so I have all my necessary imports imported. So plotly graph objects, barm layout, plotly import offline, and then from dice class import die 1 and 2. And this is from the simple class that I had made. It was the same as like in the example from the lecture. I just did the 2 so it's easier to call, and then I left the sides open so I could change them from the main program. So, and then it just returns the random integer 1 and then self sides, and same for this one. Um, so I declared both classes as simple variables so I can call them shorter um, later in the program. So I have like the lists for classes to add. So my list is for outputs. So for rolls in range of 1,000, that's the amount of times that I wanted to roll them. And each dice is for 6, so I put the 6 in the 6. And then I have variables calling the function from the class. So dice 1 roll and the dice 2 roll. And then the output, which is adding the uh, dice 1 and dice 2 rolls together, or dice 1 and dice 2 toss, even though the same thing. And then that enables me to combine them and then append them to the list for outputs. And then once I do that, I create another list, which for occurrences or frequencies, and then my max outputs for D1 sides and then D2 sides. So it's originally I thought that we're supposed to make one that was counting the occurrences of the two dices separately and then combine them. So how many, on average, like how many sides or which sides come up more common and less common. But it's actually the combination of the two added up, I guess. So max output D1 sides and then D2 sides. And then for value in range, 2, and then the max output plus 1. And then the occurrences equals the outputs. So counting the output value and then add that to the list. So it takes it takes those and then adds that to the occurrences list. And then for my visuals, the x value is this list range, and then 2 comma max output plus 1, and then my bar graph, the x values, x equals x values from above, and then y equals the occurrences list. And then my titles for the x-axis, which is occurrences. Title for y-axis or config is the occurrences of results. And then my layout, which is layout title, tosses up to D6,000 times. X-axis, which is the x-axis config, and then y-axis config, and then offline plot. So I have for data is my data from above, from the bar, calling the bar chart, and then layout from my layout called out from above, and then the file name, which is 2d6 for 1,000 rolls. And then when I hit build, shows you my graph. The most common combination is 7, which pops up 169 times out of 1,000. And then the further you get away from 7, the less likely they are. And then just for visual sake, I put the other part into a separate program, even though they're essentially the same. So for this one, it was to roll 2 dice with separate amount of sides from each other, so 6 and then 10. So I did the same thing. So it's the outputs list in range of 50,000. So it's supposed to be tossed 50,000 times this time. Still the D1 roll, D2 roll, and then adding them together as a combination, and then appending them to the outputs list. And then same with occurrences, max output, D1 sides plus D2 sides, and then appending that to the occurrences. And then essentially the same exact layout data and configurations, and then the file is just, it's just 2d6, but that's just easier to save. But for 50,000 rolls, and so this graph will be such as this. So from 7 to 12, they're the most common, but 9 is the least common out of these 5 most common. And then again, when you get further away from that section, it's less likely to have that combination. Just put that as, and then so we're gonna change from 50,000 to 100,000. Oh, that's too big. Okay. And then, yeah, so same list or same program, everything, just the values were changed for the amount of times rolled. And then, so we're going to build this one. I'm going to try to build this one. So let's see, 9, 10. So the highest ones are from 7 to 11, but 8 is the lowest out of this combination. And then again, the further away you get, the less chances you have, but still higher chances than the other ones since the probability is higher, since the amount of tosses is higher.